Morning, Algeta.
Morning.
Acknowledge the traditional owners of the land in which we speak today, the Gadigal people. Today we have something really interesting to tell you. We've completed a major exploration survey in the New Ireland Basin in June and July, and we've got some fantastic results to share with you. We've made a find of a natural gas and light crude oil seepage field. We've identified that this field is associated with a giant anticlinal structure with multi-trillion cubic foot potential. And we believe the prospects for a nascent LNG industry in New Ireland are excellent. And I think this will be good news for the people in the islands who may have felt left out over the 20 or 30 years of LNG production in the Papuan Basin. And it's actually interesting, when I first came to PNG in 1988, working at the Lihir mine, I heard the saying, Papua New Guinea is a mountain of gold floating on a sea of oil. And I'm trying to find out who actually said that first. I spoke to Sir Jay on Friday. Apparently it was attributed to him. But he said he used it, but he didn't know who it came up with. And he thought it might be Charles Lapani, and Arthur Samari mentioned that yesterday too. So quite apt here. You can see Lihir Island, contains one of the world's largest gold mines. I think it's the 6th largest gold mine. And the field that we've outlined here, the structure we've outlined here, is within 10 kilometers of the Lihir gold mine, and that contains multiple seeps issuing gas condensate. So Peak, private Australian company registered in PNG to do business. We have 2 licenses that we're operating, 352 and 625. They are strategically located along what's called a slope carbonate play. This is a new play type in Papua New Guinea. It's found in other parts of the world, Gulf of Mexico, Adriatic Sea, and of course Malaysia. What it's related to is what we call the Exotica Formation. It's a very large area that has collapsed from the northeastern side of New Ireland, and it has collapsed into the deep water basin, and all of the reefs that were present at the time, about 6 million years ago. New Ireland was covered with reefs the size of Great Barrier Reef. All the reefs that were present became a rubble field, downflow down in the deep water basin, and that is what we believe is the reservoir for petroleum system in the area. Now, on the far right-hand side here, you can see the pink unit is that Exotica Formation. That is the slope carbonate play. When this line here gets close to Lihir Island, you can see that it bulges upwards. That's a traditional anticlinal structure. And that is where, in the 1990s, a scientific survey, which I participated in, found seepage of hydrocarbons, and that made me think that this area could be prospective for hydrocarbons. So what we did in June and July, we were fortunate enough to have the research vessel Zona, a German scientific vessel, working in the area. They had a research permit, and they wanted to look at some of these seep localities. We granted them permission in exchange for getting access to data and samples. Here you can see the chief scientist, Philip Brandl, and myself, and on the ship was Stanis Kanabi from the University of Papua New Guinea, and he was one of the gentlemen who was named some of the sites that we were working on. It was 31 crew, 36 scientists, a very capable vessel. It has a ROV, heat flow survey capability, high-resolution multi-beam mapping. We have a multi-beam map of the area at 10-meter resolution now. There was a seismometer and magnetotelluric survey. Those results will hopefully show us where the fluids are in the basin, and that's still being worked up at the moment. Extensive heat flow surveys, and that was very useful for us working out where the seeps are, and there's some interesting results from that coming up. So the locality here, this is again the Exotica field in pink. We have one of the initial seep sites that was discovered in 1994. But while we were in the area, we found two more substantial seep sites, being the Karambusil seep and the Paleo seep. But in 1998, on a second cruise of the Zona, they found this methane anomaly in the water column. It was a very strong anomaly, but they didn't know what it looked like. All they knew is that there was a lot of methane there. When they took sediment samples in the area and reported them, they had very strong wet gas signatures, not too dissimilar from what was reported in the Hides gas field. But we didn't actually know what was there. So with this survey, we were able to map out that area. And you can see here there's a fault structure, and the 10,000 nanoliters per liter methane signature is this very intense colored area. And here's what it looks like. This is a fault. This is the Mussel Fault. And along this fault are located all of these strange, large mussels. They're shells that are about 10 centimeters long. And they have in their gills bacteria which eat methane. And in fact, there's a whole ecosystem here that's found. It's based around the consumption of bacteria which eat methane. Some of the other things, there's your tube worms over here. They don't want to be very close to the methane stream, but they'll find the methane in the area. And again, they have bacteria in their gills that eat methane. There's methanogenic carbonates here. This is a new thing that in Papua New Guinea, but it's quite common in the Gulf of Mexico, in the Caspian Sea, North Sea. This is the first time this sort of community has been found in Papua New Guinea, but it exists in many oil and gas fields around the world. Perhaps the most spectacular finding was, however, so here's the four seeps, Edison Volcano. This is the Mussel Fault seep site. It's 5 kilometers long. Paleo seep, it's a seep that's no longer seeping. It used to be seeping maybe 5,000 years ago, but it has all the indications there that there was seepage. And then there was this other seepage site, which I'm going to talk about next, called Karambusil. It's 8 kilometers apart from these seep localities. But when the ship was running over top of this subsea volcano, this plume of response was coming back. And it was a plume of natural gas extending 400 meters up into the water column from a field which is 21 acres in area. And this is what it looks like. It's not just a giant jet. It's multiple emissions of natural gas, continuous, on the bottom. And you can see here all of these organisms are dependent on methane as a nutrient. So here's a little bit of footage of what one of these bubble seeps looks like. It's quite extraordinary. You're probably seeing this for the first time. Very few people on the planet have ever seen what I'm going to show you now. Here we have, hopefully it works, here we have the bubbles coming emitted off the seafloor. You can see the water here is quite swirly. We've got samples of that fluid. That's actually gas condensate or light crude oil. You've heard of Texas tea. Well, this is New Ireland nectar. Yeah, quite extraordinary. And yes, so the analysis of the fluids have come back. We've got naphthalines, we've got phenols, lipones, all kinds of strange organic molecules, but it's certainly consistent with what you get in natural gas condensates. So we were able to sample by sticking one of these funnels with a titanium tube on the end of it over top of one of these gas emission sites. And here you can see the analysis from 3 of the sites, K1 to K3, and the values are relatively consistent. I've put up as well the published results, published data for what Hides gas looks like. And also here, this is the average composition of gas that's sold into the China market. So what we believe from the results is that we have marketable gas The nitrogen levels are higher than we expected, but we're happy with the CO2 being around 5% or less. Low H2S at this stage. Yes, this is a very positive outcome, and we believe that's a marketable gas. So we had a major survey in 2017 done by Searcher Seismic, a multi-client survey supported by Total. We acquired additional seismic data over the area, so that gives us quite a good coverage of 2D seismic, and it allowed us to work out what the shape of the structure is. This structure here in total is 32 kilometers long by 9 kilometers wide. The seepage locations 1, 2, 3, and 4 are located there. Interesting that 3 of the 4 seeps are actually along the hinge line of the anticline. And so we were able to look at some of these seismic lines. I've recreated here the ON02 line shot by the Koreans in 2002. This is that line there. So we have seepage coming up from piercements over a postulated reservoir in Unit C here. And you can see that the top of the reservoir coincides with the Muscle Cliff seep that I showed you before. The bottom of the anticline coincides with the conical seamount, where the gas is coming out in large volumes. So if you treated these as drill holes, you would actually say that that's currently the lowest indicator of hydrocarbons in the system, and that would mean that the minimum height of the gas column in this structure is 250 meters. To put it into perspective with what people probably know more about here, the Hides gas field, which is behind the PNG LNG project, that anticlinal structure is 30 kilometers by 5. I've superimposed here what Exotica looks like. It's 32 by 9. It is a tier 1 structure. So what are the resource estimates? Well, using stochastic modeling techniques, which are standard in industry, and looking at it from an anticlinal perspective, we have actually samples of the Exotica formation. We know that porosity of the samples that we have ranges between 6 and 15%. We know the area of the field. We know the height of the gas column, approximate height of the gas column, and minimum maximums. And with being gas, the probability of recovery is between 60 and 80%. And we come up with a P90 value for this structure at 3.6 TCF and 160 million barrels of oil, and a P50 at 7.8 TCF and 400 million barrels of oil. So what's the next steps? Well, things that we need to do, we need to find out exactly the area here enclosed. We only have one line coming through there, so we need to do some more seismic up to the northwest. We have another hotspot down here. We have heat flow data, which is anomalously high and can only be caused by the presence of seeps. The seeps haven't been located yet, but we call this structure down here Exotica South. It is, again, probably related to the Exotica formation, which is a reservoir potential. Where would the first well go? Well, we're presenting this to Minister Kua, and I'm proud to say that he predicted it would go right here at Muscle Cliff. That would be where you'd put it, along the anticline. And I said, you're well on your way to becoming a petroleum engineer, so congratulations. So what is the sort of the production concepts? Well, if you looked at the PNG LNG field, you would drill numerous production wells down the hinge line of the anticline, tie them up to a single subsea system here like you have in, this is the Ormen Lange field in Norway. It's all completely South Sea. There's no need for infrastructure above water. Very calm conditions in here, so like a bathtub many days when we were working in the area. So we think that a subsea system there could be tied back either by pipeline to New Ireland for an LNG plant. Modest amount of pipeline required, 60 kilometers. Obviously, the Lier mine is an energy-hungry operation, so we'd like to do a gas-to-electricity project there. I think they would be a major client for this low-emissions fuel. So what are the advantages of New Ireland? Well, you know, New Ireland is a lot closer to the Asian market than Caution Bay or any of the LNG plants in Australia. Here we have the average time an LNG tanker would take to get to Japan, South Korea, or China, between 5 and 6 days. That is 25% less of a transport time than it would take to get from Caution Bay. What I've shown here is this is an old slide that McKinsey came up with in 2019, but it basically shows all of the volumes of LNG being produced around the world, all the different LNG sites. And what they were saying in this slide is that, you know, to be competitive in the future, you need to get your prices down below US $7 per MMBTU. And that's one of the reasons why I think Caution Bay has been a great success, because it approximately comes in this area here. But just by being 25% closer, the shipping costs alone would bring the New Ireland LNG plant into the lowest quartile of producers. And the other thing would be there's the capital costs of building an LNG production capability in New Ireland would be a lot less. We don't need 700 kilometers of pipelines. We don't need to build airstrips to bring Antonov aircraft in. So we think that the New Ireland LNG site would be a low-cost producer of LNG. So in conclusion, New Ireland is a mountain of gold floating on a sea of gas condensate. We've had some fantastic success. We have a strong plan for moving forward. As a sort of a vision slide, I asked ChatGPT to draw for me a vision for the future where an LNG tanker would be loading up with LNG on New Ireland, and it produced this. And I'll leave that with you as a concluding statement. Thank you.